Welcome to this special edition of the review meeting. We're looking at this Kubernetes minor release today, 1.32. So this is a new format that we would like to establish. Mark and Luca will present it today. They will probably explain a bit more about it. In the agenda, you can see that we have these 5 points. We will look at graduated features, then promotions from alpha to beta, new alpha features, security, deprecations, and removal, and finally, what's changing in Gardener. Okay, then let's directly hand over to Mark and Luca and get started.
Raphael.
Yeah.
All right.
Thank you very much. Also welcome from my side, from our side, to this special edition of the review meeting. Let's first clarify why we're here. And especially in this meeting. So we thought that just like with the release responsibility, we want to bring some more formal definition into the process of how new Kubernetes versions are introduced and onboarded into Gardener. And for that, we defined a Kubernetes release responsible schedule that defines 2 assignees per release. And their main task is to update Gardener and the extensions and prepare the introduction of the new Kubernetes minor releases. And also, of course, to bump the necessary libraries that come along. Also, their responsibility will be to drop older Kubernetes versions from Gardener that are no longer supported, and to also present the changes in the review meeting, where we are at the moment. So for Kubernetes 1.32, named Penelope, it has been released on the 11th of December 2024 and also marks the 10th anniversary of Kubernetes at the same time. So this is also some specialty in itself. So as Raphael also already pointed out, the agenda for today will be first to have a look on graduated features that have been graduated from beta to GA. Next, we'll also have a look at features that have become beta or fresh off the press that have been introduced as alpha features. And we'll also have a look at security, deprecation, and removal implications. And last but not least, also take a look on what's especially changing with regards to Gardener itself and the Kubernetes version, what's changing there. If you have any questions, feel free to raise your hand or speak up. Also, in the meantime, we're happy to directly take them. Else, of course, at the end, there's also the option. Let's get started with the graduation ceremony. So the first feature that was promoted to GA has been in beta since Kubernetes 1.31 and is about custom resource field selectors. So as you can see in our example here on the left-hand side, we have a custom resource definition that exposes selectable fields. And if we then have a query with kubectl on the right-hand side, we can select on that field spec.color and filter for our, in this case, widgets that expose that specific color. Note that the example on the left-hand side is stripped down, and for the color to be shown on the right-hand side, the additional printer columns would need to be defined. That just as a side note. Also graduated, has been in beta for a longer time, is the sizable memory-backed volumes that previously defaulted to 50% of the node's memory available. And with that feature, the volume size now is linked to the pod limits if they are specified. If they are not specified, the limit is assumed to be the entire memory of the node. So the entire memory of the node would then be available for the volume. Another feature that has been promoted was in beta since 1.30. Actually, a few feature gates all related to service account tokens were the bound service account token improvements. This feature includes information about so if we have a projected volume in a pod that requests a service account, then in the service account, there's also information about the requesting pod and the node that is running on injected or included, which makes cross-referencing the identity easier with the request, and the identity is passed along a request, and allows also for hardening of identity verification and so on. So that's also quite handy. And here you can also see that, as we saw it here, we now have the information in. We can then define it maybe in a validating admission policy and check for the node name to match easily. Also, the structured authorization configuration has been promoted. We are using it more and more, and it allows for more granular control, detailed rules based on a context, and also for more flexibility, that complex logic beyond simple role-based access control or role-based permissions can be defined, and also the extensibility. So we can define multiple authorizers and define which authorizer takes precedence when, and also define our policies more granularly there. Another one is that PVCs created by stateful sets are auto-deleted, has been in beta since 1.27 and is now GA. And that simply means, as we can see it in our example here, we have a stateful set with 3 replicas, and they all have a PVC bound. And if we now go ahead and scale down the replicas to 2, we also see that the PVCs, so one of the PVCs got removed. And if we delete the stateful set, all the PVCs are automatically removed. Still, if we don't want to have the PVCs automatically or be automatically deleted, we can override that by setting the reclaim policy to retain to avoid the deletion of the PVCs when scaling down or deleting the stateful set. And this, of course, brings the benefit of reduced manual interventions depending on the use case, and also improved resource management because there's no PVCs lying around, and we can free up our storage resources in a timely manner. Exactly. So with that, I'll hand over to Mark for the beta bloom, if there are no questions so far.
Thanks a lot, Luca. waiting a second, but I don't think there are questions at the moment. As you said, let's move into the beta bloom section. So we look at feature gates that have been promoted from alpha to beta. We start with the managed by field for jobs, which is rather easily explained. So you now have the possibility to hand over the responsibility for a job resource to a custom controller, if you will, either from library or your own controller that you implemented for jobs. You can do this by setting the managed by field in the spec and pointing that to the name of your controller. This feature gate is enabled by default, and naturally the implication is that your controller conforms to the job API and ideally also passes the conformance end-to-end tests, since it has to reconcile the job then. Next up, we have the possibility to allow anonymous auth for certain endpoints of the API server. This feature gate is now also enabled by default since it's in beta. And one of the main use cases is that if you have certain non-critical endpoints on your API server, say the liveliness, readiness, or health endpoints, you can specifically say that these are always, it's always possible to access these without authentication. That would even work in case you somehow misconfigure your RBAC rules. It will still be possible to reach these endpoints without authentication. Another improvement is in the scheduler. So this is not directly a user-facing feature, but since the main KPI of the scheduler is the throughput, especially in clusters where you have a lot of churn or maybe a lot of pods running, it's important that the scheduler works efficiently. And without going too deep in here, let's just take a look at the graphic that we reused from the blog post here. Maybe most important to know that there's different queues within the scheduler. So you have the active queue for newly created or updated pods to be scheduled. You have the backoff queue based on certain parameters where they have to wait before they're tried for scheduling again. And you have the pool of unschedulable pods that wait for certain cluster conditions to change or cluster events to come in before they can be scheduled again. And basically in the past, you could say this was a bit inefficient since you just had many events coming in that basically then allowed the scheduler to maybe retry this again. But now with the introduction of these queuing hints that you can see here, these are implemented by the plugins, say, for example, the Interport Affinity plugin. The responsibility is basically clear on who decides why a pod cannot be scheduled at the moment. This decision is then also recorded. And then if you want to retry this pod for scheduling, it's clear that this queuing hint has to first say, now my condition has changed and we can try this again. So this becomes more efficient since the responsibility is clear in this case. And this feature gate is also enabled by default now. Let's just admit somebody to the session. All right, next up we have the recovery from volume expansion failures. So in the scenario that you can see here, we have a storage class with that allows volume expansion. We then have a persistent volume claim that uses the storage class. It has been created with the size here, the 91 GB bytes. And then we try to increase it to a much larger storage size, but just like the Citibank, we completely mistype, hit a too big number, and the volume resize fails, exceeds the limit. Previously, you had to then delete this PVC to try this again, but now with this feature gate, regain my focus, with this feature gate, which is also enabled by default, you can attempt the resize again with a smaller value, and if that is within the limits, your resize operation will be successful. Also in the topic of volumes, we stay here with the persistent volume claims. You now have the possibility to do volume group snapshots. Why is that interesting? You can do snapshots of multiple volumes that are taken at the same time if your CSI driver supports this. So in this example, we have two PVCs that are labeled by a certain group. We then also have a volume group snapshot class that specifies certain attributes about this snapshot. And in our volume group snapshot that we create, we use the selector for the label to target all our PVCs in this group. And we end up with volume snapshots being created at exactly the same time, which you then, for example, could use for point-in-time restores at a later point. And yeah, I didn't mention it, but this is also enabled by default. Next up, one big topic of this release was improvements or maybe an entire rework of the dynamic resource allocation feature. So in the details, amongst other things, there were standardizations regarding network interface data if you have network devices, and also an improvement in terms of structured parameters that you can make use of, which are especially interesting for the scheduler or cluster autoscaler, since now they can simulate resource allocation without actually doing so or without involving some driver. So they can do this autonomously and simulate and decide and work more efficiently. So just what we see here in the example is that we have a pod with 2 containers and certain resource claims that make use of a resource claim template. The resource claim template we can see on the right-hand side, where we have a template for a fictional device class for large black cats, which you can see using the common expression language that we can match on certain attributes of these devices here. And in the device class itself, we can do the same to match on certain device drivers. And important to note, this is not enabled by default, even though it is in beta state. All right, following this, we have another beta feature gate where you can do authorizations with field or label selectors. So this is useful in different applications. For example, in the webhook match conditions or the subject access review resource that we see here on the right-hand side. It should be rather obvious why this is useful. So it gives you a lot of flexibility on how you authorize certain things based on field selections or selecting certain labels. Another it is a user-facing feature also, is the possibility to stream data for informers. So you can read more on this blog post that is linked here. Basically, they created an artificial stress test with informers, and I think it was 400 secrets, each 1 megabyte big, and all of these informers basically performed list requests on these secrets. And you can see the memory usage of the Kube API server here. Why is this a problem? Because for the API server to send out these lists, it first needs to build up a list in memory and then send it out. And then you can basically tell along this graph that once it hits 16 informers, then basically the node was already lost, got out of memory, basically. And as long as you fulfill the prerequisites that you see down here, you now have the possibility in the client code to use so-called watch lists, where then instead of building up that result first in memory, it streams the results instead. So the Kube API server doesn't have to hold everything in memory and it's just able to stream these things. And for anything that uses the client Go library, such as the controller runtime, it's possible to enable the watch list client here to make use of this. All right. With all that being said, we move into the fresh off the press section where we look at new alpha feature gates. And we start with the asynchronous preemption feature. So what is this? It basically helps again to improve the scheduling throughput, where previously preemption operations, so the API calls that are connected to preemptions, were done in a blocking fashion and sequentially. These are now handled asynchronously so that the scheduler can pick up work elsewhere in the meantime. Yeah, here also the quick recap, right? So the preemption is a mechanism where if you configure high priority pods, they can evict low priority ones if necessary. And like I just said, previously this was blocking. Now you have parallel processing, which makes the whole scheduler more efficient. Again, this being especially useful in high churn clusters, or if you have a lot of failures maybe going on. And yeah, since we're now in the new alpha feature gates, this is not enabled by default. Next up, we have the mutating admission policies. This is probably, especially for operators, a useful alternative to mutating webhooks, where you can do a lot, again, also with the common expression language. There's various use cases that you could do here. Basically, you could, for example, add an argument to a deployment command through this mutating admission policy. You could, for example, also remove a CPU min-allowed field from your deployments, or change the way how your etcd worker pools are scheduled. So really, also because of the expression language, you have a lot of possibilities what you can do here. We have also, as a new alpha feature gate, the pod level resource specifications. So sometimes it might be, for whatever reason, difficult to decide upfront what the resource allocations for each container should be. So you can do this on the pod level, and then all containers can share basically this pool of resources. And that allows your containers, if for whatever reason this is difficult to judge, they can then just dynamically utilize or share these resources. Okay, now we move into smaller improvements. So here for the pre-stop lifecycle hook on pods, this sleep seconds field now allows 0 values. So as you can see on the right-hand side, without this feature gate or with the feature gate in the off state, your pod would be rejected as invalid because the 0 value is not allowed. In the implementation, though, this is possible. You can do a 0-second sleep, and then your natural question might be, why is that interesting? So say, for example, you have a validation or a mutating admission policy that makes sure that all of your pods have a lifecycle pre-stop hook. And maybe you just want to have a no op here just to conform to the standard, then it might make sense to put a 0-second sleep here. So that was also the motivation behind this cap to do this. Another improvement, which is probably most useful for debugging purposes, is if you enable the feature gates for the component status C and component flag C feature gates, you get on the core components, so for example, the API server, you get these new endpoints that you can reach, which clearly tell you that they're meant for debugging purposes, and hence they are not ideally machine readable, but they allow you to get, as you can see here, different information about the pod running. For example, when it was started, which Go version it uses, or the various flags being set for the component. And finally, just to note this, there were improvements again for running Kubernetes on Windows nodes. So, for example, the graceful node shutdown has been implemented just as it works for the Linux nodes today. And you also get support for CPU and memory affinity, or the coordination in between them, just as it works for Linux nodes. Okay, we move into the fourth section about security deprecations and removals. So also really just to note, there were already 2 vulnerabilities in the release version and also in the first patch version. One, again, sticking with Windows here, only affects, is only relevant if you run on Windows nodes. And the other one affects the kubelet under certain conditions. Nonetheless, it probably makes sense just to use the currently latest patch version 1.32.2. On the deprecation side, the feature gate disable node kubeproxy version now defaults to off, and this was already deprecated since Kubernetes 1.29. And the service account annotation for enforcing multiple secrets has been deprecated, and basically you should prefer namespace isolation instead. On the removals or API removal side, so as I mentioned before, the implementation for dynamic resource allocation was basically changed with the cap 4381 that we see here. That's just important to note that all of the internals changed here. And for the resources flow schema and priority level configuration, the v1 beta 3 API has been removed, and you now have the stable v1 API, which was already available since Kubernetes 1.29. And finally, what does this all mean now for Gardener, or what has changed in Gardener through this update? So first of all, if you're running shoot clusters in the future on Kubernetes 1.32, you can't use the old OIDC configuration on your Kube API server anymore. This was already deprecated, but is then now forbidden. Instead, you should make use of the structured authentication that you can see on the right-hand side here. So you can configure a config map that holds your configuration and gives you also much more flexibility in how that should work. In the same fashion, it's not possible or allowed to use the cluster autoscaler ignore tains anymore. Instead, you have the semantically more speaking fields startup tains and status tains, where you can neatly separate these tains based on their nature. Regarding the availability of the support for this Kubernetes release, so this is built into the Gardener release 1.113, which is already available. The extension for Alibaba Cloud has already been adapted and also released with the version you can see here, and the other extensions are adapted and are to be released soon. Let's go quickly over just the issue that we worked on, just to show that. So I will not go into detail, but all of the adaptations for Gardener have been done by Luca and myself. As I mentioned, the ignore tains are not possible anymore, and you should use startup tains and status tains instead. Same for the ODC config, where you should use structured authentication. The cloud controller managers have been updated. The extensions I mentioned, again, to be released soon. We also note the version when this is expected here. And maybe, as you can see, the issue is not closed yet, so we have a few follow-ups. The cluster autoscaler still needs to be updated with upstream, and a few small follow-up items, especially regarding the conformance tests. So once we have all of the provider extensions ready, we'll take care of that as well. And next up, just to show that, so I'm running a local Gardener deployment here, where I have a shoot cluster running the latest Kubernetes version, which you can see is awake and healthy and is running all the expected pods. And also that you believe us, the same is working for Ali Cloud. So we have a shoot running on Ali Cloud here, also on the latest Kubernetes version that we spoke about. And as you can see, the cluster at least appears to be healthy and working. Okay, and with that, we are through with all of our content. So thanks a lot for listening, and let us know if you have any questions or comments. I saw one raised hand, but I think it was by accident.
Yeah, thanks, Mark and Luca. So any feedback, any questions, any thoughts?
Nice summary. Yeah, this is really nice. I like this. Thanks.
Thanks a lot.
Okay, if there are no other questions or other feedback, then we can close for today. Thanks, Luca and Mark. And then we meet again next week for the regular review meeting. Have a good time. Bye-bye.
Thanks a lot, everybody.
Bye.
Bye-bye.
Thanks a lot. Bye.